Hi, my name is Maya. I work for Genevisius and focus on corporate strategic development. Today, I'm very delighted to share our thought about 5G O-RAN, the innovation in the network development, and the solution we offer. First, I believe you probably heard about O-RAN in these 2 years because it's kind of a hot topic in the telecommunication industry and greatly impacts networking development too. And many analyses look at O-RAN as a next pivot, and O-RAN is attracting a lot of investment as well. So what's O-RAN and why are people talking about it? RAN means radio access network. A radio access network, RAN, is part of the mobile network that connects end-user devices like smartphones to the cloud. This is achieved by sending information via radio waves from end-user devices to RAN transceivers, and finally, from the transceivers to the core network which connects to the global internet. And O-RAN means Open Radio Access Network, opening the traditional RAN architecture. Now, today I'm going to show you the solution we offer and also 5G, O-RAN, and private network and office we offer. Now I'm going to show you a very easy concept. You will see this arrow is the technology development progress with time. And this last block means the content of the telecom market demand. In the prior stage, the whole context can be satisfied by these 3 big components. As time goes by, some people thought the structure lacks flexibility and space to grow because every component is so big that only big players can join. So maybe we can separate these 3 components to allow more players in and stimulate the market. Hence, the second stage came out and broke the old structure. These blocks are the case old structures, so you can imagine the creativity that arrived when the old structure was transformed. Moreover, in the plan so far, the next stage will see it built into more components. Therefore, in the end, we will see a more open market system. More players are joining it and will bring more competitiveness, which means more progress can be made. Then this will increase the flexibility in your market strategy and suppliers' choices, as well as bring cost saving. So you will have more resources and motivation for innovation. And this is what O-RAN wants to do. Now you know why analysis will take it as a pivot, since it allows so many possibilities to happen. And O-RAN has 3 key features to promote the future map, including openness, flexibilities, and innovation. First, O-RAN Spec development provides specs to set up industry-wide standards for RAN and defines the individual parts of the O-RAN architecture. Second, they make the hardware and software disaggregation and open internal RAN interfaces to enable multi-vendors. Third, they provide a new way of designing and managing the network to allow for innovation. Hence, the speed of the traditional structure will be workable just like this graph. The A stage is pre-O-RAN networks. Now we are between these 2 stages that RAN systems separate into RAN software and RAN hardware. And in the long run, more blocks will build out like network integrators and node integrators. So the Y stage is part of implementation. So we came to an easy calculation when we view the incumbent network equipment vendors. There are going to be far more vendors in the Y stage than in the A stage. They will create more competitive advantage which could broaden the market scope and bring benefits. This will encourage creativities, including flexibility, innovation, and cost saving. So the most important goals of O-RAN are to automate networks, then simplify operations, and finally reduce OpEx. Now you can imagine how many possibilities ORAN can bring. The most important advantage granted by open ecosystem is the magnitude and richness of choice available. The diversity is the source of Open RAN's true power. We might say ORAN is a revolution of more than just technology. Univisio is an ORAN network pioneer. Our team has a decade of experience in telecommunication. We are very proud that we launched the world's first 5G ORAN inline PCIe UDU solution in 2020, which is the board you see here. It offloads the 5 layers of the RAN protocol stack, including real-time baseband functions and heavy D2 signal processing algorithms from the CPU. We have 3 key phrases. They are Open RAN, Open Network, and Telecom Core Network. We contribute this via our PCIe solution, and we are generating full vision, which is driving the innovation of network development. I thought you must already know the characteristics of 5G, like faster, better, and more stable. So that's because it supports eMBB enhanced mobile broadband for bandwidth driving use cases that require high data rates. And MTC, massive machine type communication, connecting many IoT devices to the cellular network, and URLLC. Ultra-reliable, low-latency communication. It's applicable in mission-critical use cases such as telecom, smart grids, remote surgery. In the projection, 5G will cover 53% of the world's population by 2025. And in 2026, ORAN will be 58% of total RAN capacity, spending at $32 billion and deployed at 65% of all sites. Traditional RAN sales will decline to $23 billion and 39% of the alternative and greenfield operators will adopt it fully in the early phase. And we can also see the market size in the 5G private networks. The private network is a new concept within 5G development. It's expected to grow to $33 billion by 2028 with a CAGR of 47%. And the vertical market is broad, including manufacturing, energy and utility, transportation, and logistics. Private networks are a great field for 5G ORAN's adoption. Now I will share the 5G solution from Univisio. Here's our portfolio. It's a suite of telecommunication infrastructure from UE side to core side, including RU, DU, and CU, the main components in RAN side. RU is a radio unit that handles the digital front end and the parts of the 5 layer, as well as the digital beamforming functionality. 5G RU designers are supposed to be inherently intelligent, but the key considerations of RU design are size, weight, and power consumption. DU is the distributed unit that sits close to the RU and runs the RLC, MAC, and parts of the 5 layer. This logical node includes a subset of the InnoB, GNOB functions, depending on the functional spell option, and its operation is controlled by the CU. CU is a centralized unit that runs the RRC and the PDCP layers. The GNOB consists of the CU and 1 DU connecting to the CU via FSC and FSU interfaces for CP and UP respectively. A CU with multiple DUs will support multiple GNOBs. The split architecture enables a 5G network to utilize different distribution of protocol stacks between CU and DUs depending on mid-hole availability and network design. It's a logical node that includes the GNOB functions like transfer of user data, mobility control, RAN sharing, positioning, session management, etc. With the exception of functions, they are allocated exclusively to the DU. The CU controls the operation of several DUs over the MIHO interface. So the data will convert it to signals and transported from the equipment of the UE side to RU, and then they will go to the server unit of RAM. In this part, DU and CU will provide multiple types of the processing for the data. Because DU plays a role of loading work from the server, so you can tell that the stronger the DU is, the more effective the server is. Hence, the server can save costs to do the other important work, or the project can just choose a server with lower specs. That is how Genevisive's DU solution can make your project more cost effective. Meanwhile, GV's DU also supports GPS functions, so you can easily have very accurate time synchronization across all equipment. And we also have an open from whole small cell that can be applied to a DU or a CU plus DU. Its fabless hardened design is suitable for harsh environment and wide temperature ranges. So you can use it for private networks either indoors or outdoors. Here we also have the IPsec timing card to provide the functions of Internet protocol security and time synchronization that could also offload additional work from the server. And in the MVC and the core sides, we will also have the UPF cards that will offload from the server on user plane functions. From our portfolio, you can see what we want to achieve is to reduce the loading of servers in multiple areas and advance all the systems to the next generation deployment. Now, as mentioned in the previous slide, private networks are a new field for 5G, so you can see the infrastructure here is the same as the one in our portfolio. Also, from the UE side, you can see the equipment from office and external environments will send the data to indoor or outdoor RU first, then go to the components of DU and CU. In indoor environment, you can plug our DU cards into the server, and DU will offload most of the work as well as provides the GPS function to synchronize all equipment. It's kind of the same in the telecommunication infrastructure. And while in outdoor environments, GV's small cell provides a convenient solution that combines several components in a fanless bus. The small bus makes the project design significantly easier and is available in wide temperature environments. This is a new development that matches the needs of 5G private networks. In our roadmap, we offer two chipset solutions including NSP and mobile. As GV's target products, most DU cards already came to market via POC programs worldwide like the UK, Belgium, India, and China. Moreover, PAC-010 already has commercial application in the telecom industry. The small cells sample will roll out in October, and UPF and IPsec timing cards are planned for launch in 2023. Now, what's the advantage of Genevisive's DU solution? So we have outstanding features including first, the time sync performance between IEEE 1588 bundling clock class C and D, far beyond the ORAN standard in class B. It supports PRTC and only have the single-digit narrow-second time error. In addition, the power efficiency is also remarkable. All the DU solutions are below 75 watts, only about 1/3 of our competitors' products. Third, GV has multiple partners that can provide a variety of packages to fulfill different scenarios. Customers can easily find reliable suppliers via GVE and save energy and time in integration. So you don't have to cook the solution from zero. We also use inline acceleration. Most of the protocols can be processed in GV's DU card and greatly offload the host CPUs. So these advantages combine to greatly reduce cost upgrading to 5G. As seen, ORAN unleashes the network infrastructure and brings many choices for market. However, it does have challenges. First, customers must choose diverse partners in the distributed architecture. This can be time-consuming and require new kinds of knowledge. Second, customer needs to ensure the integration is workable and has a good performance. This could be also time-consuming and it needs industrial experience, or customer might be delayed in this early stage for a long time. GV solves these problems by having more than 20 partnerships and decades of experience. That's our important market value. Furthermore, GV's DV has great flexibility for different scenarios on ORAN application. It's able to be configured into multi-application scenarios, including Hi-Fi inline accelerator pack, DU on NIC, and small cell on NIC. First, Hi-Fi inline accelerator pack within EC pre-interfaces, layer 1 Hi-Fi and FEC LPDC functions. GV's DU can provide inline accelerating from option 7-2 to option 6 FAPI. FAPI interface over PCIe interfaces to host server. Second, DU on NIC. Within DU inline accelerating functions and make RLC running on LS2160, GV's DU can provide full DU functions from option 7-2 to option 2 F1. F1 interface over NIC interface on PCIe to host server. Third, open from host small cell on NIC. Within DU and CU functions like BTCP, SDAP, etc., running on LS2160. GV's DU can provide full DU functions from option 7-2 to N3. N3 interface can be over NIC interface on PCIe to host server or one or from panel fiber Ethernet interface. This application offers customers lots of flexibility to use GV's DU card in diverse deployments. GV has taken the early lead in 5G ORAN DU solution. After launching the world's first inline PCIe DU solution, in 2021, NAS, GV demoed the end-to-end 5G base station with Austria DU software. This achieved great performance, such as commercial 5G handsets that greater than 1 gigabit throughput and low latency with 400 US traffic. In the block diagram, you can see the PAC-010 series use one LS2160 and two LA1201, supporting 4 ports of 10G or 25G fiber interfaces as the front-haul connection. IEEE 1588 2BC and PRTC in Class C comprehensive time-synchronized interfaces input and output, including 1 PBS, 10 MHz, 1 PBS differential and TOD with high accuracy GNSS receiver. Considering the memory expansion, the board provides 2 SODIMM slots as memory, which is up to 64 gigabits in total. The PAC-010 series is a single PCIe slot with 4 high, a third 4-lane 4-factor can be easily installed into code server via the PCIe 16 connector. So the 5G RAN can be built up with less complicated steps and OPAS. PSC-012 is a low-profile version, half high, half length, as small as your hand. For customers, the server space is valuable because so many components need to add to the server, right? Or sometimes customers just need to choose a small server. then this low-profile product can match the needs very well. Single low-profile PCIe slots with PCIe 4 connector and 2 ports of the 10G, 25G fiber interfaces as the from-hole connection. Supporting up to 16 gigabit memory, which can implement multi-scenarios in ORAN like DU accelerated DU and open from host small cell. And if you look for Marvell solution, PAC-012 is a choice. It also supports 4 Ethernet ports and IEEE 1588 from-hole interfaces and multiple time sync interfaces. Additionally, it has an IEEE 1588 management interface. In these products, as well as strong GNSS functions and premium power consumption, PAC-010 can support 350 44R 100 MHz. PAC-010-P is 4cc 44R, and PAC-121 is 1cc with 16T 16R. This can satisfy most of the market demands. So about the 5G small cell with open from hole, it's a virtual DU with an LS2160 and 2 LA1201, supporting up to 4cc, 44R, and 100 MHz. Through the cloud deployment, it can be small cell with open from hole, means DU plus CU or DU only. Small cell with open from hole is an essential ingredient of flexible deployment for 5G ORAN. Open from hole provides RU connectivity to a small cell to fulfill different radio technology and radio bands from sub-6 to mmWave. It offers good flexibility for different installation DIN rail or wall mount systems with only 85 watts of power consumption. Also, it's a fanless model for industrial environments with extended temperature support from -20 to +65 degrees C. Perfect for outdoor industrial environments. Private networks top solution. So that's all we want to share with you today, and thank you so much for attending this session. If we can help you with anything in the 5G ORAN solution, please feel welcome to contact us, and it will be a pleasure to help you. Thank you.